We've talked about some water sampler issues already. We've talked about bottle flushing and sampling water samples in terms of what orders that you do. And also on Wednesday, we'll talk more about troubleshooting and maintenance. And so we'll talk more specifically about how to maintain the actual water samplers. But I just want to talk briefly too about some of the other aspects of that. So again, we've already talked about this is the 32 water sampler again. And just as a reminder, this is the 55, SB55 Eco water sampler. So this is your smaller package to use on the smaller ships. And then in terms of software, so again, if you're going to use an AutoFire module, you actually have to select AF, which just stands for AutoFire, for your terminal. And then typically V2 should work for most systems. I'd recommend starting with V2. If you've got an older computer, it didn't work properly, you can always go back and use CTerm AF V1 if you'd like. One of the main differences between why you have to use this terminal program and the CTerm is that the AFM has a cool ability. You actually plug in directly to your AFM or your SB55, and you can actually talk to your CTD through that. It's like magic. There's a fourth pin. It's called the DTR pin. Based on what setting you have in this software, you can tell it whether you want to talk to your CTD for 19 plus V2 in this case, or if you want to talk directly to the AutoFire module. So the reason I bring this up is because probably this is the most common problem that we hear with using these is just using the wrong cable to communicate. So if you use the standard cables that we use today, the regular CTD cables, they don't have pin 4 hooked up to anything. And so oftentimes you just have to make sure you use what's called the AFM cable, so it basically has pin 4 hooked up. And just to show you some examples too of some AutoFire options, you've actually got 3 different options that you could use in terms of AutoFire capabilities. The 17 plus is what would work with the 9. The AutoFire module, or the AFM, is commonly used with a 32 water sampler. And then if you've got one of these Ecos, which is again the newer version, smaller version, it actually has the ability to act as an AFM inside. So it closes the bottles, but it also acts as the AutoFire module at the same time. So you don't need one of these if you've got the 55. So anyway, back to the software. So you can actually hit connect to either one. So it's really handy. You actually go to setup, make sure you choose which model CTD you're using and whether you have an AFM or Eco. And then you can select all these different communication options. Well, let me talk really briefly about the logic for how to program it. It's easy to forget how the logic works, and I always have to remind myself too. When the AFM decides it'll close a bottle based on what pressure data it gets. Typically we recommend to close on upcast. Another option that you can use is close when stationary, and that's if you have the ability to either estimate depth using wire out, or if you've got another way, you can pause the CTD and close bottles and give them more time to flush. But just in terms of how the logic's working, what you can do is you can set it to basically close a bottle once you get close to the bottom. Let's say you don't know exactly how deep you're going to take the CTD. You know it's roughly 100 meters, but you're not sure if it's exactly 100 meters. But you want it to close the bottle when you're at that bottom depth. What you can do is you'll set the pressure that you want to have this enabled. So if you're going, in this example, you're going to 100 meters. You need to get to at least 100 meters before it's going to sense that. But because it can be, maybe it's 95 meters and you thought it was 100, I recommend not setting this to your actual depth that you're going for. Usually we would set this to about half the depth we expect, or 2/3. This will actually tell the AFM, okay, start paying attention. Start paying attention. We're going to get ready to fire bottles at some point. So it just wakes everything up, gets the system ready. And in this case, I would set this to 50 or 75 if I knew I was going to 100, for example. And then what that tells me is that after I get past 50 meters, okay, now wake up, start looking for some of the other criteria to be met. And then the other criteria that it has to meet for the bottom bottle is it either has to meet, here's an either or situation. Are you ready? Ready for this? Okay, so it either has to meet the pressure decrease to determine upcast. So what that means is how much are you raising the CTD before it figures out what the upcast is. So in this case, we have 10 decibars, so that means you have to raise it up at least 10 decibars in pressure before it decides, okay, now I can fire the bottle. But in this case, we want to have a bottle while stationary, right? We don't want it to do that while it's moving. So we also have these last two things. So this is an and situation. So basically, it has to be, the bottle has to be in that a certain pressure window for a certain amount of time. So in this case, we chose 5 minutes, but we might choose 2 or 3 minutes. And then we might select what our pressure window is, taking into account the ship heave. Let's say in our example, we have 2 meters of ship heave. So if we go to this plot, basically, we want to make sure that the bottle would stay within a window. And so think of it plus or minus 2 meters. So the ship, heaves to one side and then it heaves to the other side. So potentially we could be seeing a 4 meter difference there within that whole window. So the CTD could be moving up and down 4 meters. So in that case, we'd want to set this to at least 6 meters, for example, or to be safe, you might set it to 10. And then in some cases, you might not have any ship heave at all. So you might choose, 2 decibars as your window, which is about 2 meters. How it determines upcast is it has to stay in there, in this example, for 5 minutes within a 10 decibar window. Let's say you don't meet this. Let's say, and it's in a 12 meter window. And let's say it's just going up and down, or you didn't hold it for 5 minutes. Maybe you only held it for 3 minutes. You're not going to meet this logic anymore. So now what it does, it actually reverts to this other logic. So let's say you've raised it up 10 decibars. Now it's going to say, okay, I'm doing the upcast. And now it actually starts, and we'll close the bottle then. And then again, I mentioned the stationary logic. So the way that works is it's very similar to the bottom bottle logic, but it's for every bottle, not just the one on the bottom. So basically you have to hold it within a window for a certain amount of time, and you can fire off multiple bottles at that depth. So I definitely recommend using the pressure data. And again, the way that works is it takes the pressure data from your CTD, is transferred to the AFM. So we just talked a lot about the closure logic. Let's say you want to have other bottles close at different depths. So the way that this is generally configured is you do your deeper depths, we're going upcast. So we've got our deeper depths, and then we're decreasing our pressure as we raise our CTD. So now we've got our shallowest water sample near the surface. What happens is the CTD records the auto fire module, also records another file, .afm, and this is actually very similar to a .bl file. So this is for real time. So if you're in CSAVE and you're firing bottles, you'll get a .bl for real time. Auto fire module, you get a .afm. And basically that records a few scans of CTD data when the bottle was actually fired. I'm sure some of you who've used 911s or real-time systems on ships have some experience with terminating the end of the C cable, right? That comes up. That generally tends to be one of the most common failure points on those big shipboard CTDs is that pigtail that goes from that long C cable that comes off the winch, goes through the block, goes down to the CTD, and then it gets unplugged, plug back in, unplugged, plug back in. And so it definitely gets the most stress and use. And typically, if there's any moisture that gets in there, it can cause noise in your data, or it may make things stop working altogether. And then this is just in here for your reference in terms of, cable specs. Typically, C cables usually have been single conductor, and so that the actual armor of the cable is used as the ground in some situations. And this is just a diagram for your reference to you. Again, this is really up to the ship's crew to make sure that this is all configured properly. What the deal is that when you have this properly cabled and when you have a proper ground, you shouldn't have to worry about ever getting electrocuted when your ground's configured properly. There isn't a reason to get electrocuted by powering up your CTD on deck. But for safety's concern, and because it's really up to the discretion of the ship and what the ship's crew feel comfortable with, maybe they're worried about a break in the cable or something that could happen if someone was handling a cable with a break in it. So I could see why there's also some ships' practice is to never power up the CTD when anybody's touching it. And again, let's say you're not using the armor as ground, and if you don't have your that center conductor grounded to anything else, I have heard possibilities about when folks were recovering their package that they got a little shock, just a little static shock, not 250 volts, but they got a little bit shock, I think, from similar to this. So they got actually the ground, the return, and they maybe got a 30 volt DC little shock when they recovered the package, because it wasn't actually grounded properly to anything else. Okay, then the last thing we're going to talk about is plumbing for success. So we'll actually talk in detail about configuring the instruments and why we actually pump our CTDs. All right, so oftentimes if you got it configured vertically, you'll see this is the tubing that comes out from the conductivity and temperature sensors, and you'll often see this air bleed valve. I just want to point this out because this can be a point of issue is this thing gets clogged and you don't have air bleeding properly. So that's another thing to check. You want to make sure everything's plumbed properly. Another thing that you'll often see is the exhaust of the CTD will be on the same plane as your intake. And that's done intentionally, and that helps prevent flushing as your CTD is going through the water. It doesn't accelerate the flow rate, basically, if they're on the same plane. Here's an example of horizontal orientation. So really the goal with this, any type of plumbing like this, is you want to make sure that your intake is at the lowest spot and your exhaust is at the highest spot. And this just helps to prevent any kind of bubbles from getting trapped in your CTD, because that can really affect your data quality. And of course, make sure everything is packaged well. And what can happen is if you've got any cable ties that are kind of flapping loose in the current, those are kind of messy. But when you do cable ties, make sure that you don't yank them on as hard as possible, because that'll actually wear on your cables over time too. We'll talk more about that on Wednesday. But this just has to do with making sure you've got a clean flow path to your CTD intake at all times. What is the fish? So that's a slang term that's been around for ages, but that's also referred to as the fish, versus the deck unit is the unit that's on the ship in the dry lab, where you receive the data from onto your computer. Has anybody ever seen there's a switch on the deck unit too? You can switch it over from fish. Fish means it'll communicate with your 9+, and then there's another switch that goes over that says tape. Anybody know what the tape switch does? Yes, it's for hooking up your VCR, so you can record the data to your VCR. Isn't that great? That's so useful. That's a historical thing. I think there's one person out there in the world who still uses that, and so we haven't gotten rid of it. But everybody else has upgraded since then. Computers used to be slow, and there wasn't a lot of memory available, so you could actually record data to your VHS tape, and then you could play it back on your deck unit later. So just keep in mind that switch is a lot of boats I've seen or ships will have the tape, that switch actually physically taped to the to the fish side, so no one can switch it back, because if you switch it over, you will lose communication with the CTD altogether, and it will beep at you, gives you an alarm. So anyway, that's what this has to do with, is when sometimes you'll hear folks say, make sure you soak the fish. I don't know if anyone actually says that. But what that means is that, and this goes actually for all CTDs, all profiling CTDs, we do recommend soaking prior to starting the profile. And generally, you're going to want to soak for at least 2 to 3 minutes. A big purpose of the soak is to bleed the air out of the system. So it allows for all the air bubbles to go out from the plumbing, for the pump to turn on. The pump turns on, it wets all the sensors. So there's some warm-up time, and things like your oxygen sensor takes a little bit to warm up and start reading values. Conductivity and temperature are pretty quick, but it also kind of gets rid of the thermal mass on your package too. You might have had it out in the hot sun on the deck. So any kind of heat that your big CTD package has, it allows time to kind of for that heat to dissipate. And so it just gets everything a moment to equilibrate. And that's one of the reasons why we say that. And when you do soak, we want to make sure that it's deep enough that it's not coming out of the water. There's a lot of ship heave and swell. That's a challenge. So in those kinds of situations, I would recommend just lowering it even deeper. So you can soak it at 10 meters in those situations, and then it'll be deep enough that it's not going to go up again. If you're in a shallow area, it's pretty calm, you could soak it just below the surface. So the soak depth isn't important per se. It just makes sure that you don't allow everything to come up again, because when it comes up, you can inject air bubbles into your plumbing, and those can be problematic, especially when you're working in shallow depths. Once you get below generally 10 to 30 meters, the air compresses and will bleed out of your package. But especially if you want good shallow data, it's a good idea to make sure that all the air gets out. Does anybody use their CTD in cold places like the Arctic or Antarctic, below freezing temperatures? Yeah, occasionally? Okay. So CTDs work just great in those situations. It just oftentimes you just have to be more attentive to sensors. Sensors in particular, the glass conductivity cell. So it is glass. So you want to make sure it's not filled up with water, and especially not fresh water if there's any chance of freezing. It's a good idea if you're gonna, if it's gonna be stored overnight. Some groups I've seen too, they'll actually just wrap blankets around the CTD while it's in transit to help keep the heat in. And then another thing you can do is you could make a seawater solution if you're ready to wet the electrodes. But really, I'd recommend just storing the cell dry. You can store conductivity cells dry, and then you can just inject some water, maybe half an hour or so before you're going to do your cast, to wet the electrodes on the cell. And then the oxygen sensor, the chemical electrode type oxygen sensor, the SPE43, is susceptible to freezing. There's a membrane over there, and then there's an electrolyte that's inside the head of the sensor. And so that electrolyte can freeze and cause the membrane to burst. So that sensor you definitely need to protect from freezing. If it's going to be really super cold, you can even take it off the CTD package, and it's a small sensor. Just take it into the lab overnight or someplace warm, and then put it back on the CTD when you're ready to deploy. Yeah, so general practice is oftentimes you'll see there's a syringe on the bottom of the CTD, and you'll keep the conductivity cell full of water. You can use distilled water, deionized water. You can also do a dilute solution of Triton X. And the Triton X just kind of helps if there's any oils on the surface of the ocean while you're going down. The Triton X helps move those oils along. But yeah, it's good to keep your electrodes wetted when you're getting ready to deploy. For long-term storage, though, you can store it dry. Yeah. Just this is actually going to be in here for your reference. There's an activity about how to create bottle summary files. So basically, when you send your CTD down and you take samples with the water sampler, it marks. You get a separate file like we talked about yesterday, the .bl file, or if you have an auto fire module, you get the .afm file. So that basically just marks the raw data. It marks raw position, but then that file is pretty raw, so it's not helpful necessarily until you process it. So you want because really what you're interested in is temperature, salinity, converted engineering units. So when you did, just like you did data conversion, when you did data conversion yesterday, you can actually create one of these .ros files only. Oftentimes it makes sense to create both a .cnv, which is your converted data, and a .ros file at the same time. So that just takes all the information. And you have to have your all these files, your .hex, your .xmlcon, and your .bl or AFM, they have to be in the same folder. As long as you've got those in the same folder, you can select all of those, and you can create both a .cnv and a .ros file. Just to talk briefly about some of the setting options that you've got. So oftentimes I recommend doing both upcast and downcast, because then you can get additional information from the upcast. It's good because it gives you information that you might you need in terms of how your sensors are working. Gives you more information for troubleshooting as needed. But generally your cleanest data is going to be on your downcast. And then what you can do also is you can just select where you want to use for the bottle data. And then in this case, we've got a bottle confirm bit, so we used it with an 11 deck box. And so each scan where the bottle, basically each time a bottle was fired, there'll be a mark scan that's sent back to your file. And this actually just allows you to select how much time that you want to include. So one of the reasons for this is, let's say you don't want just a single point. Your CTD in the case of a 911 is sampling at 24 times a second. So you don't necessarily want just a single piece of information. And this is also you have to think about what your hold time is, and whether you want to take some of the data from prior to when you fired the bottle, or whether you want to take it after you fired the bottle. You have to think a little bit about hold time. And remember, we talked about yesterday about the allowing some time for the bottle to flush. But in this case, we're looking at 6 seconds of data. So the 0 point is when the bottle closed. And so you can collect 2 seconds prior, and then for a total of, actually that's a total of 2 seconds prior for a total of 4 seconds of data. So that means it's collecting 2 seconds prior to when it closed, and then 2 seconds after the bottle closed. You can select a certain amount of scans, so how much information that you want to average together, so you're not just taking a single point from your CTD. So it gives you all that information. So let's say you want to average that information. Let's say you collected 2 seconds of data at your soak depth. Well, the next processing step that you do is you take your .ros file and you turn it into a .btl file. It's not intuitive naming, so that's why I mentioned it. So this file is now, it's a summary. So you've got an average temperature, salinity, density, any other information that you want. You've got that collected for that depth. And so that's just an overview of the steps